So this test is on Wednesday. Another place you can get extra review, practice tests and answers are up on Blackboard. Also, if you just go to the end of your final exam review, it's all the Unit 4 stuff on there. So it's more problems that you have answers to if you want. So for the first set of problems, it's all about solving quadratics, which is what we did up to the point at which you took your quiz. So there's also extra practice on Blackboard for these if you haven't done it or if you want to do it again. Make sure you use the specified method or you don't get any credit even if you get the right answer. So the first thing we're looking at is the square root property. And this was when you have something squared equal to a number. It's when you want to use the square root property. Square root property is basically just that taking the square root gets rid of a squared. So for this problem, I'm going to take the square root of x plus 1 squared, which means I take the square root of 18. And I'm doing that just to get rid of the squared. But what else do I need in front of the square root of 18? Plus or minus. Or else I lose half my answer. So square root property always has that plus or minus. The square root and the squared will cancel on the left. That's why we use the square root property. So I get x plus 1 equals plus or minus the square root of 18. And to finish solving for x, I'm going to subtract 1. And where do I put that negative 1 on the right side? Before the plus or minus. So I have x equals negative 1 plus or minus the square root of 18. Am I ready to box that answer in? No. No, why not? I can break up that square root of 18 to be the square root of 9 times the square root of 2. And you will have your yellow cards. You will have your yellow cards to help with the radicals. So we're looking at x equals negative 1 plus or minus 3 square root 2. Do I need to necessarily write that as two separate answers? No. It's got a square root or it's got an I, you can leave it stacked. If it doesn't, that's when you have to break it up. Emily? The time you would split it is if it were like 3 plus or minus 5. Because then you could do 3 plus 5 is 8, and 3 minus 5 is negative 2. But if you have a square root or an I here, you don't need to split it. It's only if you have a number there after the plus or minus. Any other questions with our square root property? All right, number 2. My number 2 for some reason is not your number 2. X squared plus 5x. We want to determine the constant that should be added to the binomial, so it becomes a perfect square trinomial. Then write and factor the trinomial. That means we're trying to fill in the blank. And then we want to factor whatever the problem is that we created. How do I fill in the blank? B over 2, and then what do I do with that result? Square it. But in this case, b is not even. So when I go for b over 2, I get 5 over 2. Doesn't divide. That's okay. I'll leave it as a fraction. And then square it. Now, a couple of options for squaring. You can either just distribute the squared, or squared just means multiply that fraction by itself. So you get 25 fourths. So up here, the constant that completes our perfect square trinomial is 25 fourths. Now when b is even and we get whole numbers, it's really easy to factor because we say what multiplies to c adds to b. But this one shouldn't take any more work to come up with that factor. What number is going in right here? 5 over 2. Whatever b over 2 was. We don't always look back to it if it's an easy enough problem to figure out, but that number is always what goes in the factor. So if it's a fraction, just look at your b over 2. That makes your factor.
Or could you write it the other way? Could you do x plus 5 over 2 parentheses and then x plus 5 over 2 parentheses?
That would would be okay for this problem, but when you get to number 3, it's not going to help us at all. But yes, for this particular problem where it's literally just factor, I'd be okay with that if you just wrote the factor out twice. Any other questions? So what I'm really looking for is this right here, but somewhere in your work you have to show me that the number that finished the trinomial was 25/4. Emily? No, if you FOIL it, you're just going to get back this right here. Because the final direction was factor, so we don't want to undo that. Any other questions? Our next method to solve the equation was by completing the square, which is going to combine number 2. It's important to know your setups here. So the setup for 1 was something squared equal to a number. What's our setup for completing the square? There's 2 things that have to be true. Variable terms on the left. It's one of them. Equal to our constant. Numbers on the right. That's our equal to C. There's one other thing that has to be true to complete the square. Not X. Something has to be 1. A has to be 1. So we've got A equal to 1. What we don't have is variable terms equal to our constant, so we're going to start by adding the 16 to both sides. So I have x squared minus 8x. Leave yourself some space to complete the square. That's our blank, like a number 2, equals 16. Keep the balance. And a blank on the right side as well. And it's really, after your setup, it's just a straight combination of do problem number 2 on the review and then do problem number 1 on the review. So to fill in the blank, it's just like number 2 above. To fill in the blank, we take b over 2 and square it, which is negative 8 over 2. And then we take that answer and square it. Negative 4 squared tells me I'm going to fill in my blanks with 16. It's just by chance that there's already a 16 in the problem. But to fill in the blank, you do the process from number 2 above. So that tells me that on each side I need another 16. What am I going to do with the left side? X squared minus 8x plus 16. Make it a binomial square. We're going to factor it. Just like, again, the left side is literally number 2 from above. So I need the pair that multiplies to 16 adds to negative 8, which is negative 4 and negative 4, which, again, you can get right from here. It's always this number that ends up in your factor. And then on the right side, 16 plus 16, we just add those together and get 32. And now this looks just like number 1. And we can go back and we can solve it by the square root property. So I'm going to take the square root of x minus 4 squared equals plus or minus the square root of 32. Squaring and square rooting on the left side cancel. X minus 4 equals plus or minus the square root of 32. Just solving it now like number 1. Add 4, put it in front of the plus or minus. So x equals 4 plus or minus the square root of 32. So after you complete the square, you just go back and solve it like you did number 1. Am I ready to box? No, why not, Sarah? Okay, how would we break it down? $16 and 2. And again, you will have your yellow cards. So I'm going to have x equals 4 plus or minus 4 square root 2. That's my final answer. I don't have to break that up because it's still got a square root in it. So completing the square is a little bit of a longer process because it combines number 2 and number 1. Questions? So our last method for solving quadratics is the quadratic formula, which you do have to have memorized. So quadratic formula, again, good thing to know on all these problems is start with your setup. What's my setup for the quadratic formula? Well, that's your that's the actual formula, but what's the setup? What has to happen first so you can get A, B, and C? It has to equal 0. You can't do anything until it's equal to 0. So it's a quick fix, just add 5 to both sides. So I have 3x squared plus 6x plus 5 equals 0. Now you can go to x equals negative b plus or minus the square root, b squared minus 4ac all over 2a. So we have a is equal to 3, b is equal to 6, and c is equal to 5. So it's just a matter of substituting. Watch your signs, especially if b is negative. It's always best practice to use parentheses everywhere you substitute in a number. So I'm just going to my formula, substituting in my a, b, and c, but you can't identify a, b, and c until it's equal to 0. And then it's just a matter of simplifying. So I have negative 6 plus or minus the square root of 36 minus 60 all over 6. So negative 6 plus or minus the square root of negative 24 all over 6. So are there any questions just on substituting the numbers in and doing that initial condensing it down, initial simplify? So now that we have our answer simplified, what's the first thing we simplify in the 3-term fraction? The square root. Always the square root first. So the first thing I need to deal with is the square root of negative 24. How can I break that up? Square root of negative 1. And what about the 24 though? What would I do for 24? 4 and 6. So that square root is going to get replaced with 2i square root 6. That's back from unit 3. So square root of negative 1, it's imaginary. Square root of 4 is 2, square root of 6. So if I just put that back in, I have negative 6 plus or minus 2i square root of 6 over 6. Is there anything else I can do to simplify this? Yes. This is where you then, after the radical, you look at the triangle of numbers. You don't include the I, you don't include the square root. It's just whatever number's out front here with the other two. And you're looking for a GCF to all 3 of those. What's my greatest common factor to all 3 of them? 2. So I'm going to divide them all by 2. So I have negative 3 plus or minus I square root of 6 over 3. Am I ready to box that answer? Why do you say no, Robert? You agree? Ashley? It's imaginary. We need it in the form a plus bi. This is a big mess of a and bi. So this actually goes back to the end of Unit 3 where we divided complex numbers. This one worked out to be more simplifying than I intended. I'll say that.
So is that going to be this bad?
Most likely not. Yeah, this is literally the longest it could possibly be. And I honestly didn't intend it to be that way. But it's imaginary, so you gotta do the 2 separate fractions. But what happens when you split it up? The negative 3 over 3 will simplify again. Again, this is literally as much simplifying as you will possibly ever imagine to see. And it's all getting it down to the form of a complex number. So that is the most you could possibly, which wouldn't you rather see the most instead of seeing the least and then I give you the most? Right? Because what? I can only go back from here.
Yeah, I would this on this and on the test.
So that's every type of simplifying you could possibly imagine. So we are reviewing, going over all of the types of simplifying. Yes?
Because this was on the Xamarin, we didn't break it down to this point. We did the dot points, even though it wasn't in the direction.
It will be in the directions on your test. Yes, I forgot to update the review directions from last year. It will be on the test to write complex numbers in the form A plus BI. So any questions on your quadratic formula? Now number 5, solve by the method of your choice. You will see probably at least a couple of these. Method of your choice, I don't care. There's definitely a best method for this problem, but when in doubt, always use the quadratic formula. If it says solve, when in doubt, quadratic formula works every time. You've got to be a little careful with the quadratic formula here. I'm not going to use it because it takes longer than it should, or longer than this problem should. But if you want to use the quadratic formula, what would A be for this problem? 1. What would B be? 0. I don't have, remember our form is ax squared plus bx plus c. It's not just first, second, third. It's with the x squared, with the x. I don't have the with the x term. So b would be 0. C is the constant, the number by itself. C would be 8. So make sure if you're going to rely on the quadratic formula that you properly pick out a, b, and c. It's not just first, second, third. A is with x squared, b is with x, c is the constant. Anyone have a better method, a simpler method for solving this? Yeah, solve. Do you know what that method's called? No, the square root property. I can very easily get this set up as something squared equal to a number. Again, when in doubt, use your quadratic formula, but make sure you can properly identify a, b, and c. What I would do is I would just subtract 8 from both sides. So I have x squared equals negative 8. And then to get rid of the squared, take the square root. Don't forget to throw in your plus or minus. So I just have x equals plus or minus the square root of negative 8. It's much quicker than the quadratic formula, but the quadratic formula will work. You'll get the same answer.
Can I ask a question? What's the difference from x equals plus or minus square root of 8 and x equals the square root of negative 8? If you don't have the plus or minus.
You're missing half the answer because if you just have the square root of negative 8, this answer is, we still have to simplify it, plus the square root of negative 8, negative the square root of negative 8. There's 2 answers there. And if you don't put the plus or minus, you're only telling me half of what makes that true. How do I simplify the square root of negative 8? You're going to have an I. Yeah, square root of 4 times the square root of 2. So we're looking at x equals, plus or minus is still in front. Don't try to move the plus or minus over. It was in front of everything, so even if I rewrite the square root of negative 8, it's still in front. So I have x equals plus or minus 2i squared root of 2. Which is 2 answers. There are 2 values that make this true. Positive 2i square root of 2 and negative 2i square root of 2. And you're missing one of those answers if you don't put the plus or minus. Questions? Yeah, and method of your choice, I don't care. When in doubt, quadratic formula. Works every time. Number 6, find the coordinates of the vertex for the parabola defined by the given quadratic function. This is in that kind of funny other setup that we only dealt with the vertex in. If you forget how to do this, the long way is to write that twice, FOIL it, distribute 3, and then use our other process. But there's a very quick way to find the vertex here. Vertex is a point, x and y, and you almost get those right in this setup. This number right here is almost x. What has to change? The sign. So change the sign. So it's a different sign for x. And then what's my y value? this answer on the end. Sorry, this number on the end. This one keeps the same sign. But there's no real work you actually have to do in that format for the vertex, which is what makes it nice. But we didn't go any further with that. But if it's in that formula where you have a binomial squared, switch the sign for x, keep the sign for y. Questions? Now 7, determine whether the given quadratic function has a maximum or minimum value and find that value. Does this have a max or min? Minimum. How do we know it has a minimum? A is positive, so A is 2. And when A is positive, what direction is this opening? Upward. So we know it opens upward, and the general picture for upward is the U parabola. And when it opens upward, we know that the vertex is a minimum. And we can tell that just looking at the sign of A. Getting our shape. Is it the top or bottom? Now the second part says find that value. So finding the vertex has two parts. The first part, we need a little formula for x. How do I find x? Negative b over 2a. It's that front part of the quadratic formula. So a is 2, b is negative 4. We actually don't need c in this problem. Watch your negative signs. There's a negative in the formula and a negative on b. I need both of those. So it's negative negative 4 divided by 2 times 2. It's positive 4 over 4. Gives me an x coordinate of 1. In this regular form, ax squared plus bx plus c, it's that little formula. This is what we did most often. Where do I get the y coordinate from? Now that I know x is 1. Yeah, plug that back in. Substitute back into our function. So we're looking for f of 1, which is 2 times 1 squared minus 4 times 1 plus 3. Exponent first, 2 times 1 minus 4 plus 3. 2 minus 4 plus 3. And now just a reminder, just so there's came up a lot in the last test. Once you get down to addition, subtraction, just work left to right. A lot of people were trying to do the addition first, but not treating it as a negative number. So 2 minus 4 is negative 2 plus 3 is 1. So the vertex is a minimum. It's one thing we have to say somewhere, and the vertex is the point 1, 1. So this is our more standard form, ax squared plus bx plus c. Got that little formula there. And then we start into word problems. There's actually 4 different word problems on here. The last 2 we won't get to, but I will have them recorded and I will provide the answers on Blackboard. So our first problem, your factory produces lemon-scented widgets. You know that each unit is cheaper the more you produce, but you also know that the cost will eventually go up if you make too many widgets due to the cost of storage of the overstock. Has anything there helped me yet? No, so just be careful when you have a lot of words that not everything is contributing to the problem. The guy in accounting says that the cost for producing X thousands of units a day, so that's what X stands for, it's your thousands of units a day, can be approximated by the formula. Formulas are always good. Let's pay attention to this formula. 0.04x squared minus 8.504x plus 25,302. And then there's what we want to find. Find the daily production level that will minimize your cost. So if I look at that function, how am I going to minimize my costs? What's the point called on, if I were to graph this, what's the point called on this graph that is the minimum? The vertex. Vertex is always the max or min of a quadratic. It's quadratic, it's got our x squared. So I'm looking for the vertex. It's quadratic, I want to minimize. So we're going to do our x equals negative b over 2a, just like above. Negative 8.504 divided by 2 times 0.04. Double negatives turn it back to a positive, which is good because we can't produce a negative number of widgets. And when you divide those, you get like 160. Do you have it, Ashley? Did you get that far? No. Okay. 106.3. Now you might say, well, how can I produce 0.3 widgets? Well, X isn't the number of widgets. X is the number of thousands of widgets. So thousands of units. It tells you right there, X is thousands of units. So it's 106.3, and I'm not going to be picky with the labels on these, but it tells you X is thousands of units. It's just in your problem. It should tell you what your variable stands for. Does that answer the question? I want to find the production level. So how many widgets I'd have to make. Do I know how many widgets I'd have to make to minimize my costs?
No.
Then what did we just find? X, but what does X stand for?
Wait, so do we just fill 106.3 into the original one?
Well, if we fill into the original equation, then we're solving for C. What does C stand for? It's actually not. It's all part of the minimum. There's no maximum if your parabola opens upward. C stands for the cost. So C stands for the cost. X stands for the number of widgets. Did I ever ask you how much the cost is? I want you to minimize your cost, but did I ask you what is the cost? No. So you're done. I just want to point out, you don't always have to do both parts. I mean, if you really want to be safe, you could take your time to do both parts, but all this asked for was how many widgets, minimize the cost. It didn't ask you what the actual cost was. It never asked you for C, so you don't have to do the second half here. It's just a, no, I don't want to deduct points if you do more work than you have to. But I'm just saying, you don't have to do more work here. If I asked you what is the, and find the cost, then you do both parts. Similar to if you look at number 9, a person standing on top of a 112-foot building throws a ball vertically upward. There's our quadratic that models the height, which is S of t in feet, t seconds after it's thrown. Question, after how many seconds does it reach its maximum height? Question, what is the maximum height? 2 questions mean you have to do both parts. Sometimes 1 question means I only need the second part, so you still have to do both anyway. But keyword here is maximum. What type of function do I have in this problem? That negative 16t squared plus 64t plus 112. What type of function is that? Quadratic. It's got t squared. Just like from unit 1. It's quadratic. And where do I find a maximum in a quadratic? Begins with a V. Vertex. Anytime you're asked to maximize or minimize and you have a quadratic, it's always the vertex. 2 parts. First is, we don't have x, we have t, so I'm going to do t equals negative b over 2a. If you put x, it's really no big deal. Negative 64 over 2 times negative 16. So negative 64 over negative 32. Gives me 2 seconds. Now, if you get a decimal point here, don't worry. It's possible to have like 1.5 seconds, 2.5 seconds. All you don't want is a negative. You don't have negative time. So that's the first question. After how many seconds does the ball reach its maximum height? Where do I find the actual maximum height? So I know the time.
Is this the one where you fill?
This is where you fill it back in. It's got the 2 questions.
Okay.
It's asking you for both the time, which is what we're getting for our x here, and then it asks you for the height. So the maximum height, we're going to go back to our function and substitute in 2. So you do have to pay attention to what it's asking you for. So I'll start with your exponent. So negative 16 times 4 plus 128 plus 112. Negative 64. And you could do this in many fewer steps. I'm just doing everything because I'm working it out. So it's 64 plus 112. So I got 176 feet. Yeah, once you show me what you substituted in, if you want to put the whole thing in your calculator, I'm fine with that. I'm not testing your arithmetic. So at 2 seconds, we're at the maximum, which is 176 feet. Don't be alarmed if you have a decimal. Decimals are okay. You just don't want negatives. You have parts of seconds. And the way you pick out these problems is you see that you want to maximize or minimize something, and your function is quadratic. That's the vertex. Questions? All right, on to graphing. Graphing are our last long problems. So, number 10, find the following information of the quadratic function and graph. F of x equals x squared plus 8x plus 12. Is this opening upward or downward? Upward, because a is positive. So we know when we connect our points it should look like this. If it doesn't look like this, there's probably something wrong with your points. Vertex, we have just done 3 times. This is the 4th time. So we need A is 1, B is 8. We actually can use C later on in this problem. So C equals 12. So vertex, we should all get the vertex right. X equals negative B over 2A. Negative 8 over 2 times 1. Negative 8 over 2, and negative 4. There's 2 parts to the vertex. There's 2 things you have to do. That's just the first half. If you want to plot, you need the second half where you substitute negative 4 in to the function. And again, when you substitute, I'd like to see what you substituted, but if you want to use a calculator from there, you're welcome to. This is 16 minus 32 plus 12, which actually gives me another negative 4. So you do both parts of that all in the vertex. And it happens to be the same coordinate here. It's not always. I mean, we saw right up here. It was 2, 176. Any questions still on the vertex? How about x-intercepts? Where do I find the x-intercepts? Set the whole thing equal to 0. What we're doing is we're saying that y is 0 when we set the whole thing equal to 0. And now it's up to you how you solve this. I don't care. When in doubt, quadratic formula. If you really like completing the square, it wouldn't be bad here. Since a is 1, I would try factoring. Still might not work. But we can find a pair that multiplies to 12, adds to 8. 6 and 2. So I would just go ahead and go back to Unit 1 and solve this by factoring. It's the most efficient. Again, quadratic formula will work as well. But this gets us right down to our answers without too much simplifying. There's no square roots, nothing like that. We get x equals negative 6 and negative 2. How many points do I get out of that? 2, because those are both x values. You can't put 2 x values together in a point. You have to put in an x value and then a y value. What is the y value that always pairs with my x-intercept? 0.
So that's how you want the intercept?
Yeah,
Not
that's how.
x equals negative 6, negative 6.
Right, because when I ask for an intercept, intercepts are points. All of these are points, so I'd like to see the complete ordered pair. And if you forget any part of this, do the parts you know. Everything is worth separate points here. And again, graphing is also usually on your final exam.
So, quick question.
Yeah.
If you want to use the quadratic formula,
Mm-hmm.
and I got all the way to negative 8 plus or minus 4 over 2.
So you can either triangle and divide them all by 2, or you can just do negative 8 plus 4 over 2 is negative 4 over 2, which is negative 2. And then negative 8 minus 4 over 2 is negative 12 divided by 2, negative 6. Just split up the plus or minus part. Y-intercept, that's the easy one. 12. Which half of the point does the 12 go in?
The right side.
Yeah, it goes in for y, and what's the x value?
0.
And where did that 12 come from?
C.
Yeah, it's just C. So they don't really need work. Again, if you forget all the others, hopefully remember that one. It's just 0 and then whatever C is. All right, so let's plot these points. We get our graph. So first they have, and you have the funny graph because the 12 doesn't fit on a regular graph. And I remember to change the grids finally. So our vertex is at negative 4, negative 4. X-intercepts are at negative 2 and negative 6. Your axes will be labeled on your test, so you don't have to do so much counting. And then my y-intercept is up at 12, which is why we had to use the funny grid. 1, 2, 3. 12. All the way up here. And if you'd like, remember there's that imaginary line that comes out of the vertex that can give us a point symmetric to the y-intercept. It's completely optional. Just gives you a little bit more balance. We see that the y-intercept is 4 units to the right of the axis of symmetry, which means that there is another point 4 units to the left. Just if you want that extra balance, if you're missing points, it's a good one to have. You don't need that one without it. We certainly have enough information to sketch our parabola through them. And make sure you connect those points in the correct shape. If you just plot a bunch of points, and you don't connect them, I do take off points. It's not a graph. It's just a set of points. So there's our parabola opening upward. Questions? All right, number 11, state the domain and range of each graph. What type of graph is on the left? A whole, like 2 sections, 3 sections on this type of function. This is our exponential. What type of graph is on the right? It's a parabola. Parabola comes from what type of function? Quadratic. Now I didn't ask you to label them, but it's just helpful to know the shapes that we had for our graphs. Because what's the domain of any exponential? Negative infinity to positive infinity. Range. For range of graphs, you're always looking for the bottom of the graph and then the top of the graph. Negative 4 is the bottom of the graph, and then it's going up to infinity. But with an exponential, are we ever reaching the negative 4? No. So how do I show what's my notation to show I don't get there? Parentheses. Parentheses are I never get there. Brackets stay included. But that's why it's good to know your shape, that exponentials never actually get to that bottom value. Quadratic domain. Negative infinity to positive infinity. There were no trouble spots. We looked at that in our notes. No trouble spots for our x's. It's just negative infinity to positive infinity. Now these ones you have to look at because depending on which way it opens will affect where the infinity is in your range. Always look for the bottom of the graph first. So if I'm looking for the bottom of this graph, where's it going? Negative infinity. And then I'm looking for the top of this graph, and what value is at the top? 6. With a quadratic, am I including that value? Yes, so I need the square bracket here.
So what happens if you put the wrong bracket? Is it wrong or do we just get a point?
Just get a point off. Exponentials don't include the values. Quadratics, the vertex reaches that value. It's an important difference, and that's why it's good to know what type of shape it is so you have an idea of what you're looking for. All right, 12 is our last long problem. graph f of x equals 2 to the x minus 1. State the domain and range of the graph. The directions on your test will be a little bit different. I will specify find 5 points, a minimum of 5 points. What should also tip you off that you need to just work on finding any 5 points. Now, it's good to use negatives, zeros, and positives. In class, we always did these values right here. And then, what's that?
You have to do 5.
Yes, it will say a minimum of 5. This one, actually, you could fit 3 and 4 on there as well if you wanted. Gives you a little bit better picture, but I don't specify what values, but I just say I need 5 points to get that picture. So now it's boring. You just do this over and over and over. But hopefully it's some easy points. Again, your final exam people, they love graphs. Because these numbers are both in the exponent, you subtract them first. So you do 2 to the negative third. How do I deal with negative exponents? 1 over. So this is 1/8. Now 1/8 is something you may be able to conceptualize. If not, you can always put these into decimals. You can always graph decimal approximations. That's not a problem. Then we're going to do it again. 2 to the negative 1 minus 1 is 2 to the negative 2. It's 1 over 2 squared, which is 1/4, or 0.25. Then we're going to do it again. 2 to the 0 minus 1 is 2 to the negative first, which is 1/2. We're going to do it again. F of 1 is 2 to the 1 minus 1 is 2 to the 0. What's anything to the 0 power? 1. If you don't remember it and you are not sure, just put it in your calculator. So that's usually the point that people accidentally get a dip in their graph where they shouldn't. And then we're going to do it again. They're not exciting, but there's not a whole lot to remember here. You get 2 to the first, which equals 2. And if you did some other points, you'd also could get the point 3, 4, the point 4, 8. Those are just other options. You don't need those on there, but they would give you a more complete picture. You only need 5. And even with those 5, when you go and plot them, so 1/8 isn't up very much. 1/4 is just a little bit higher. 0, 1/2, 1, 1, 2, 2. I mean, you could start to see your curve there, enough that you could, sketch through it. If you have those extra points, it just gives you a little bit, more complete graph, but whatever you need to get it drawn, minimum of 5, it will be in the directions. But one important thing to think about looking at our function is, where does this level off? What value does this graph level off at? 0. And we can tell because there's no big number added or subtracted after the function. So we're pretty close there with our 1/8 for what we can draw. So just make sure that that flattens off there. Now the other question is domain and range. What is the domain of any exponential? Negative infinity to positive infinity. If you haven't done your final exam review yet, they also love domain and range questions. Range. Where is this graph flattening out at? 0. It's not 1/8. People are thinking that what they picked for the smallest point is kind of the end, but what you're looking for is that there's no number added or subtracted here to shift the graph up or down. If there's no big number after your exponential, it always starts at 0. If there was, say, a plus 2 there, then you'd see your graph leveling off at 2. If there was a minus 4 there, you'd see it leveling off at minus 4. So then you could change the front number, but we're going up to infinity. Questions? All right, these next ones are actually pretty quick, so we'll get through probably 4 or 5 of them in a few minutes. 13 and 14 are just to write it in its equivalent form. You don't have to do anything else. So to change to exponential form, take your base, go to the other side, equals the number that's left. And it's the same for going back. When you want your logarithmic form, you start with the base of your exponential, go to the other side, equals what's left. It's a very simple rewrite problem. Oops. Thank you. My circle cut off my 1. Yeah, 6 to the 4th equals 1296. Now we can use that same idea to evaluate. So what do I need to add to number 15 so that I can rewrite it? What else do I need in number 15 so that I have a complete equation so that I can rewrite it? Yeah, equal sign. We don't know the value, so we'll just call it x. Because once I have an equation, then I can rewrite it as an exponential and solve it. So 5 to what power gives me 25? 2. So that means x equals 2. Or you could say log base 5 of 25 equals 2. But I'm okay with x equals 2. Either one of those. Any questions on our basic rewriting? My question for you, what if this equaled a fraction? There was 1 over. What would be true about the exponent if this equaled a fraction? It's just a negative. And then you'd still look at to what power. 16 and 17 are ones that people typically miss, so those are we'll probably finish with those two. Find the domain of your logarithmic function. Write your answer in interval notation. What part of this gives me the domain? The parentheses, the 2x minus 5. And what's true about the 2x minus 5? For a logarithm. Yeah. But I mean, I need something here to solve greater than 0. So it's similar to square roots, except there's no or equal to. Just think logs are very related to square root domains. They just don't have the equality. So I have 2x is greater than 5. And to solve for x, I'm going to divide both sides by 2. So I see x is greater than 5 halves. It's okay that it's a fraction, but we do need to put it into an interval. And which you don't need the number line, but which side of the number line is greater than 5 halves? The right side. And am I including 5 halves is always the last question. I have yes, I have no's. Do I have any equality? No, I don't have or equal to. It's strictly greater than. So we're going 5 halves up to infinity, parenthesis. Logs will always have parentheses. They don't have brackets. We don't ever include that number. And then the last one I want to do is 17, just because this is, in the history of me teaching the class, probably one of the most missed questions on this test. Solve the exponential equation. What do I need in common to solve exponential equations? Common base. Don't forget this part. This is where people get lost. I need a common base for 4 and 8. 2. I can't use 4 because I can't do 4 to some power to get me to 8. It looks like I should, but they're multiples. They're not powers of each other. My common base here is 2. So I'm going to rewrite both sides with a base of 2. So 4 is 2 squared. Just going to replace the 4 with 2 squared, and then bring down the exponent it already had. Use parentheses if it's a binomial. And then how can I rewrite 8? 2 to the 3rd, 2 cubed. And what do I do after I have a common base? Cross them out. So I have 2 times 2x minus 1 equals 3. You need to, for your exponential equations, you need to get the common base so you can cross them off.
Are we going to have the charts for these two?
No.
No.
But they'll be familiar numbers.
Okay.
So it'll be bases of, 2, 3, 5. And that's all I do there. And then we're left with a linear equation that we can solve. So I get x equals 5/4. But for exponential equations, what you're looking for there is your common base so that we can cancel it out. Questions? Emily? so for number 18, first thing,
You said that will be on YouTube, right?
yeah,
Okay.
this will be on YouTube. First thing we have to do is rewrite it as an exponential. So I'm just going to switch my form to be 7 to the third equals x. And then depending on your where your x is will determine what you have to do. But for this problem, we just have to evaluate 7 to the third power, which is 343 is equal to x. For number 19, solve the equation, give the exact answer, then use a calculator to obtain the correct answer to 2 decimal places. The key here is to remember what we can replace natural log with. Natural log is a log base e. And once we have that information in, we can switch our format to be our exponential format. So our exact answer, what we need is e squared equals x, but we also need the approximate answer, which using a calculator, you can get rounded to 2 decimal places, 7.39. And for number 20, another word problem. In 2006, the population of a small country is 2 million people. Then we have our exponential growth function, a equals 2e to the 0.0035t. So the population after t years. We want to project the population for 2025. So the first thing we need to know is how much time is elapsed. You don't substitute the years in, you substitute in how many years have passed, which is 19 years. So I have 2e to the 0.0035 times 19, which you put that into our calculator, 0.0035. Make sure you use parentheses around the exponents. Everybody's is a little bit different. So rounded to 1 decimal place is 2.1 million people. And then finally, number 21 is from 7.8. The volume V of a gas varies inversely as the pressure. So V varies equals K. Inversely means divide as the pressure. So if the volume is 240 centimeters cubed under a pressure of 30 kilograms per centimeter squared. So that's our complete set of information. Our volume is 240 when our pressure is 30. So now we can solve for K by multiplying both sides by 30. And we get K is equal to 7,200. So I can rewrite my equation with that number in place of K. And now I'm able to answer the question. What is the volume of gas if the pressure, so we're given a pressure, is 45? So make sure you read that carefully to know which variable to substitute in for. But here we have a pressure, so it's going in for P. So we want to divide 7,200 by 45, and we get the pressure, volume. The volume is 160, and our volume had units, centimeters cubed. Not as worried about the units here, but the volume is 160.